Dear students, welcome to CSIR Virtual Laboratory video demonstration on electrochemical biosensor. This video is presented by Electronics and Electrocatalysis Division of CSIR Sikri, Karikudi. To develop this glucose biosensor, we used the glassy carbon electrode as a working electrode. Initially, this electrode need to be cleaned. This has been carried out by polishing the surface of the electrode on a microcloth using progressively decreasing size of alumina slurries like 1 micrometer, 0.3 micrometer and 0.05 micrometer respectively. After polishing, the alumina slurry was removed by ultrasonication either in isopropanol or ethanol and then in water for at least 3 minutes each. Surface cleanliness is analyzed by the electrochemical technique, namely cyclic voltammetry, so called CV, a most popular technique in electrochemistry. CV is performed by using platinum wire as a counter electrode, saturated calomel electrode as a reference electrode and pre-cleaned GC electrode as a working electrode respectively. The electrolyte consists of 5 millimole of redox molecule, namely potassium ferroferricyanide solution along with 0.1 mole KCl as a supporting electrolyte. CVs are recorded using autolab instrument within the potential range between minus 0.5 volt and 0.8 volt versus saturated calomel electrode at a fixed sweep rate of 50 millivolt per second. A pre-programmed GPES software is used for this study. As you can see, initially it starts with a non-Faraday background current and then after 0.1 volt the current started to increase due to the redox reaction. It displays a beautiful peak for the oxidation reaction during the forward scan where Fe2 plus is converted into Fe3 plus. Upon reversing the scan direction, one can see the reverse peak due to the reduction where Fe3 plus is converted back to Fe2 plus, thus exhibiting a perfect reversible reaction. The formation of redox peaks confirm the surface cleanliness of the electrode. After that, a disposition of 1 mg per ml of multi-walled carbon nanotube in isopropanol water mixture was prepared. An aliquot of 10 microliter is drop casted on the surface of cleaned electrode. Then this modified electrode is dipped in glucose oxidase enzyme solution for at least 6 hours. This process helps in the immobilization of enzyme on the multi-walled carbon nanotubes coated electrode. Finally, it is stored in the desiccator before the analysis. Such a glucose oxidase enzyme modified electrode is analyzed further using CV studies by using oxygen saturated phosphate buffer as an electrolyte. Oxygen gas could be bubbled for at least 30 minutes for saturation. During CV analysis, one can see the appearance of beautiful redox peak, the formation of peaks in both the forward and reverse scan direction. This arises due to the redox species, namely flavin adenine dinucleotide FAD and FADH2 present in the enzyme. One can measure the loading of enzyme on the electrode surface by measuring the charge under these redox peaks. Then for demonstrating glucose sensor, a known quantity of glucose is added to the electrolyte from the stock solution and stirred for a few minutes. Then the corresponding CV is recorded over a potential ranging from -1 to 0 volt. As you can see, compared to the CV of enzyme modified electrode, before the glucose addition, the current is increased due to the reduction of hydrogen peroxide produced from the enzymatic reaction. The enzyme glucose oxidase reacts with the analyte glucose, producing gluconolactone and hydrogen peroxide. Hence, by systematically monitoring the increase in current due to enhanced reduction of hydrogen peroxide, the glucose level could be determined using electrochemical method. This clearly demonstrates the utility of electrochemical biosensor for the detection of glucose. Hope you all enjoyed this video. Thank you very much.